Hi, my name is Michael Robinson. I'm a research associate at the Institute for Sustainable Food Systems at KPU. Today, I'm here to talk to you about DIY automatic roll up sides for high tunnel production. If you're anything like us, spring and fall weather can be very tumultuous, and with that comes constant monitoring of your high tunnel temperatures. We've created this video to introduce low tech, affordable DIY options for automating the roll up sides that come standard on most high tunnel kits. Most systems are very simple. You need a 24-volt DC motor available from many greenhouse suppliers, a PID controller, a power source, and a double pole, double throw electric relay. The motor you need will come with 2 limit switches attached to it. This is key as they allow you to set the travel distance for the roll-up sides. We've used 3 different motor mounting systems with various levels of success. Top mounted with a DIY bracket, which you use the standard roll-up bar for, a half-width swing arm on a pivot, and a full-width swing arm on a ground pivot. The system works because the electric relay works as a switch. When the relay is off, the motors turn clockwise and roll down the sides of the high tunnel until they hit their limit switches. They then stay in place until the relay is turned on. When the relay turns on, the polarity of the motors is switched back and it turns them counterclockwise, which rolls up the sides of the high tunnel. We control the relay with the PID controller. The controller has a temperature sensor, which it uses to turn on or turn off a flow of electricity based on temperature parameters we set. We use that electricity to turn on our relay. So when we hit our target temperature, the controller turns on the relay, which switches the polarity of the motors and opens the high tunnel. When the temperature moves outside of our temperature parameters, the controller turns off its flow of electricity, which turns off the relay, switching the motor polarity back and closing the high tunnel. We've installed systems with 2 types of power inputs. For an off-grid system, like the one at the Tsawwassen Farm School, we use 2 12-volt batteries installed in a series. Depending on the time of year, the batteries needed charged between every week or every month. We've also installed an AC system which plugs into a wall outlet. In this system, we use an AC to DC 24-volt converter. One final thing, depending on the PID controller you end up using, you may need to install a 24 to 12 volt converter. We ended up doing this on both of our installs. We just found it was easier to find a 12 volt PID controller. Thanks for watching. We hope this video was helpful or at least can inspire some low-tech creativity for other growers. For a detailed plan or help installing your own system, check out our website and feel free to reach out anytime.